Hello everyone, I'm Kirtana from group number 501. Today I'm going to talk about our project lexChat. What is lexChat? So lexChat is basically a legal assistant AI powered chatbot which answers all the queries or questions related to legal domain of the Indian judicial system. So instead of reading the whole long books and getting confused with the laws, you can ask any questions related to legal domain to our chatbot. So the main pipeline which is used here is RAG, which is retrieval augment generation, so that the information is retrieved correctly and then the response is generated to give a correct and accurate answer. With this, it also supports chat history so that it remembers the context of what the user asked earlier, so that it doesn't treat the new question as an independent one. So the key features which we are having is hybrid retrieval. Instead of only keeping the lexical matching, we have also introduced lexical matching plus semantic matching so that it understands the context correctly. It supports multi-turn conversations, and the important part is LLM as judge evaluation. Instead of a human judging the responses generated, the LLM itself judges it and scores out of 5. Token budgeting is present. That is, we dynamically adjust the tokens for number of conversations length and also the conversational history. Query rewriting. Suppose we ask, usually we ask what is that. So instead of that, it replaces with the context. That is what is Article 21, etc. And we also have debug transparency where it shows all the tokens used, what was generated by the LLM and so on. So this is the architecture diagram. Starting with the front end, we did in React.js so that the user interface is more interactive, and it undergoes asynchronous calls to the backend through Axios for REST API calls. Next is the backend or the middleware where JWT user authentication takes place, session management takes place. For each session, a unique session ID is created to keep track of the multi-turn conversations. Next, the RAG pipeline is called. Basically, the corpus is undergoes data pre-processing and divided into chunks. These chunks are then converted into vector embeddings and stored in vector store. Now, when the user gives the query, these are also converted into vector embeddings, and lexical and semantic matching takes place through FAISs and sentence transforms. Here we have hybrid retrieval engine. We have BM25 for lexical and FAISs for semantic matching. And through this, the top K chunks of the data is retrieved, and this is sent to the Grok API LLM where it converts to a human readable response. And all this is stored in MongoDB so that it is helpful for multi-turn conversations. And we also have a feature of LLM as judge, where the LLM itself acts as the judge and gives scoring according to some criteria. Now, this is then the output is again shown in the front end for the user. So this is the data flow diagram. First, the user interacts with the front end, and then the HTTP request is sent. Post request is sent with the active session ID and the user authentication token. In the back end, the JWT ensures that it is authenticated and logs it to the MongoDB. Then, when the user writes the query, it is sent to the rack service, where first query pre-processing takes place or query rewriting, where if the first question is what is Article 21 and the next question is key features of that. So that keyword is now replaced with Article 21. So the model understands the context. Next is conversation context retrieval. All the initial conversation which was stored in the MongoDB are retrieved to understand the context properly to answer the next question. Next is hybrid retrieval. Here, parallel execution takes place. BM25 is for lexical matching. That is, it matches the keyword. It doesn't understand the meaning. Whereas vector semantic matching is, it understands the context and meaning. It is done through FAISs and sentence transformer. Now, these both are fusioned with RRF, that is reciprocal rank fusion. Then we also have token budgeting, where it dynamically adjusts the tokens for conversation history as well as the documents retrieved. Next, the LLM generation takes place where it gives human understandable answers, and it is done through Grok API LLM 3.18b. And evaluation is optional. Then these responses are sent to the backend and through that to the front end. So next is the architectural changes from milestone 1. We moved from a fragmented architecture to a microservice architecture. The major changes were we added unified hybrid RAG where BM20 hybrid retrieval where BM25, FISS, and RRF was present. BM25 for keyword searching and FISS for semantic searching. And the earlier one where Python node links were weak. Now we added REST API, and also JWT REST API was introduced for more secure authentication. And by improving all this, the scalability increased and almost 83% accuracy also increased. So this is the tech stack and tools used in our project. For programming language, we use JavaScript and Python. JavaScript for both front end and back end, and the RAG pipeline is written, everything is written in the Python. The libraries and frameworks which we use for front end React to build a component based application, which is interactive and dynamic, and Axios for asynchronously sending REST API calls. In backend, we use Express.js, which is a framework of Node.js, and also added JWT authentications for more security. So for RAG services, we use Fast API. FISS is Facebook AI similarity search, so that we can search easily the semantic meaning. Sentence transformer are used to convert text to vector embeddings, and rank BM25, it is for keyword searching. So for LLM, we use Grok API Llama 3.8 billion to generate the response. Next is the developer tools. We use VS Code, Postman for API and endpoints checking, Git and GitHub for version control systems. And the database which we use for MongoDB, it stored user information, chat history, session IDs, etc. And FAIS is index store. It stores the all the legal documents, vector embeddings are stored here. And for now, it's working locally. We have not yet deployed, but in future, we might deploy in one of these platforms. There are few mathematical formulas involved. First is hybrid retrieval and BM25 vector fusion, which is reciprocal rank fusion RRF. So this is the formula. Here K is a parameter used to normalize the ranks after the result, and RRF is the fusion score. For next is tunable parameter alpha, 0.9 indicates that 90% of the weights were semantic search and 10% were lexical search, which is priority shift. Whereas if alpha is 0.5, it is balanced retrieval, and the performance gain, that is hit at the rate 3 accuracy, which measures that at least one document is most relevant among the top 3 documents, which gave us 83.8% for hybrid, and in case of vector only, it was 72%. For semantic search, we have sentence transformer, which converts text into vector embeddings, and we used All-Mini LM L6V2, and similarity metric is cosine similarity, and the formula is this. So the hit at the rate 3 accuracy is total questions with at least one relevant chunk in the top 3 by the total questions in the benchmark. Algorithmic pipeline. First is the RAG pipeline. It loads the Grok LLM, performs context retrieval, that is hybrid retrieval. It manages tokens, that is token budgeting, and orchestrates the retrieval argument generation. The token parameters which we have is model max tokens. These are the total amount of tokens which can be taken by the LLM during a single prompt. Reserved response tokens, these are subtracted from the model max tokens so that it ensures that the LLM after generating has certain amount of tokens to store data. Retrieve K, it retrieves the top K relevant documents. Context selection involves hybrid retrieval and storing the chat summarizations of the chat history. Next is the evaluation pipeline. It includes LLM as judge, which gives scores based on factual, citation, clarity, completeness. Let us know the parameters involved. First is alpha. It is the tunable parameter in RRF, which balances the semantic and the keyword search. So it indicates the weight of the semantic search versus the weight of the keyword search. Model max token, it sets the token limit for input context. That is how many tokens the model can take at the single prompt. Reserved response tokens, these are the tokens subtracted from the model max tokens so that it ensures that the LLM model has enough space to store the response. Retrieve K, it retrieves the top K most relevant chunks of data. Sentence transformer converts the text into vector embeddings, and FAIS index type, it helps in semantic searches. Some of the key learnings which I learned from this project are hybrid information retrieval technique. We came to know that combining BM25, FISs, and RRF would give more accurate, good results than just trying only one type of retrieval method. And we were able to design and implement the rack pipeline from end to end, which is multi-turn and multi-layer. Also, the LLM quality varies across dimensions. We came to know that after this project, as for every query the llm is it is not uniform, it performs differently. We came to know because of these factual citation quality, factuality quality, etc. And parameter tuning is also very crucial, as we did fine tuning of alpha in rrf. The potential improvements which can be done are, instead of doing fixed size chunking, in future we can introduce a hierarchical chunking so that it gets processed according to the section or act. And we can also improve the re-ranking models like using BERT and multi-hop reasoning. For complex questions, it must hop from one chunk to another, even if they are not adjacent ones. Summarize, turn-to-turn summarization can also be improved in future. Also, the fine-tuned evaluation metrics. In real world, it is useful for law students. Instead of reading the whole 100 pages notebook, they can instantly know what an act or a section means. And it is helpful for lawyers during their cases for a quick reference. We can also integrate this within the government portal so that anyone having a legal query can use it. It also helps citizens to know their rights. Now this is the performance analysis. The hit arithmetic accuracy when we had hybrid and vector only when we use separately. So these are the results. For easy citations, the hybrid was 100% and vector only was 70%. So it tells that for easy citations, the vector only would not work. Keywords matching is very important. For medium citations, it was overall same. And for hard, the hybrid was more, which tells us that semantic as well as lexical is important for hard citations. And the averages for hybrid, we got 80%, and for vector only, we got 73%. Next is LLM as judge evaluation. As we know, it evaluates on factual accuracy, legal reasoning, clarity, citation quality, and completeness. So it scores each one of it out of 4 out of 5. So factual got 4 out of 5, etc. And the overall score is 4 out of 5. This is LLMS evaluation dashboard. Uh, the before picture shows only about one query or one question, but this shows the overall performance. There were few challenges and which we overcome. Initially, the retrieval quality was very low, so we introduced hybrid retrieval, that is keyword searching as well as semantic searching through FAISs and BM25, and we also had a reciprocal fusion ranking. The token limitation was also a constraint for us. The context was getting long, so we introduced summarization. That is, the chat history would get summarized if the token limit is over, and also chunk level context filtering. We also introduced LLM as a judge for detailed legal quality assessment. Instead of human doing the assessment, the LLM itself does it. And also, the major problem was connecting the Python-based RAG with a Node.js one, and we overcome it through MongoDB Bridge and REST APIs. So even though we have reached till here through lexChat, but there are few limitations. Like if there are any amendments or changes in the judicial system, they won't be reflected here until and unless we provide that data and do the whole pre-processing and vector embeddings. Next is there is lack of human verification. For some sensitive queries, human verification is required, and also to check that the LLM model is it aligns with the current legal ethics. The computational cost is also high as we are using the Grok LLM model. It is very large model and also involves token budgeting. And the model accuracy also depends on the model. Sometimes LLMs may hallucinate or give generalized answers. So let's see the demo of our project. Firstly, we have to run the front end. As it takes time, I already ran. Next, backend and the rack services. So this is the home page. Let's log in. We can create new chats. So this is the answer. If we enable this, we can see the LLM as judge evaluation. We got the response. And this is the evaluation for this particular query. To see the overall evaluation, we have to go here. We get the overall score. Like this, we can ask n number of questions. Our model also supports multi-language, but since it's not working in my computer, I'm showing you the demo. We got in Hindi language. Now we are trying in Telugu, and we get the response in Telugu. Thank you.